Okay, this is Mr. Peterson, and we're looking at notes for section 15B and 15D. The first thing on tap here is learning how to do the substitution method. So we're going to look first of all for one of the variables, x or y, that has a 1 for a coefficient. So this one here is a 3, that won't help us. This one has a -2, but when I get here, I found pay dirt. That 1x right there is what lets me do the substitution method conveniently. You can always do it, but you're going to avoid fractions if you use that 1x to start with. You got to get that x by itself, so that 4y is going to go over the other side. So now you have an expression that replaces x. You can replace it with -4y plus 20. And we replace it or substitute on the other side. So you're going to say 3 times that new expression for x. I'll write it in there. And then the rest of it, which is up here. And this side only has one variable in it now, so we can solve for y. We'll distribute the 3. Collect like terms. Subtract 60 from both sides. And finally, we'll divide by -14. And a little calculator work here. Give me a second. 84 divided by 14. I think I know what it is, but I better use my calculator because I've been making lots of mistakes. Anyway, you get 6. So now that new information substitutes on the other side. You now know the value of y. And that takes you all the way down to -4 for x. So you put it in point format to finish the job. X first, y second. And that problem is done other than checking it, and I'll illustrate how to check it. If you want to see if it's right, you're going to take this -4 and put it in place of that x. So 3 times -4, which is -12. And then you would take the 6 and put it in place of that y there, and that gives -12. So -12 and -12 is -24. And you could likewise put those x and y values over here. In fact, you should if you want to be sure it's right. So let's do it once. X is -4 times that 1. It would be -4. And 4 times 6 is 24. So -4 and 24 adds up to 20. And you've confirmed that you've done all that work right. Okay, here's another example of this. So I'm going to start by putting them side by side here. And I'm looking for a 1x or a 1y, and I don't see one. However, I see a -1y, and that will do. We can take that over the other side to clear the negative sign, and in the process, I'm going to bring the 4 back. So we'll end up with 3x minus 4 is the same as y. That means we can replace this y with that expression. So 6x minus 6 times the expression 3x minus 4, which over here says that's the same as y, and then equals 28 to finish that out there. So we'll distribute here. 6x minus 18x plus 24 equals 28. Collecting like terms first and subtracting 24 off both sides takes me to that point. Dividing by -12 here finishes the job for the x. You get -1/3. and this is canceled. So we now know what x is. I'm going to go ahead and write negative 1/3 here for the x. I'll anticipate the answer. Now that information comes over here, and you're going to replace this x with negative 1/3. So you multiply 3 times negative 1 is negative 3, and divide by 3, you get negative 1 minus 4. In case I went too quickly there, you multiply a whole number times top and divide by the bottom. Anyway, that gets you down to our y value of negative 5. And 2 down. Okay, so this next one here, we're scanning the problem here, and we notice that there's a 1y right there. So that tells me I want to get that by itself. I'll add 4x to the other side once I get my correct tool here. So it's going to be y equals 4x plus 8. And that's going to go on the other side of the line over here. And that replaces the y. Y is equal to that. Now I just replaced this y with that expression, but I also have the minus 16 down there. Okay, distributing. So these y's cancel, and if I bring that over the other side, I get 8x minus 8x equals 0. Collecting my like terms gives 0x, and you end up with 0 equals 0, which is always true. And if it's always true, we have a dependent system. And these systems are really the same line twice, and they have an infinite number of solutions. So we say infinitely many solutions. And there's the abbreviation you guys can use. Okay, so that last example kind of leads me into those two special cases. And I've got them listed here. If you come up with a mathematical impossibility, something that's never true, then you see I worked that out and I got 0 equals 4. 0 is never equal to 4. And these are the ones that are parallel lines, inconsistent, no solution. But if you get the one like on the previous problem, where you get something that's always true, like 0 always equals 0, then it's a dependent system and you have infinitely many solutions. Okay, we're switching methods now. We're going to look at the elimination method. And then in the elimination method, you're going to try to get rid of the front variable. You can see I've got a 4x and an 8x. And since 4 and 8 both go into 8, I'm going to shoot for 8x here, and I want it to cancel with its opposite. I'll have to double that top line to make that work out. So for instance, here's that 8x right there. And then keep multiplying here. It's not technically the distributive property because there's that equal sign there, but you can treat it just like it. So then you got a 30 down there. And this one we have to multiply by negative 1, which has the effect of changing all the signs in the problem. And when you add these lines, you've eliminated the x. So now we have negative 8y equals 48. And dividing by negative 8 gives y equals negative 6, which you then bring up and put into that top equation. Let me substitute for y here. And once you have it in there, you just solve for x. We're going to subtract 18 off both sides. And divide by 4. So we get a fractional result for the x this time, negative 3/4. And we get a negative 6 for the y. There's your answer. Okay, we're going to do another example just like that. We have these numbers here, 6x and negative 9x. These both go into 18, so I'm going to shoot for an 18x on the top and a negative 18x for the bottom line, which means we have to triple the top line. And the bottom line just times 2. And you may notice that this cancels. In other words, you get 0x. And this also cancels, so we get 0y. And over on the other side, negative 6. So what we have here is 0 plus 0 equals negative 6. In other words, 0 equals negative 6, which is flat out never true. So this is one of those ones that if you graphed it would be parallel lines. These are called inconsistent systems. And they have no solution. Okay. This problem, if you were to work it all the way through, has an answer of negative 2,6. I've included that there. It's not my intention to work this whole problem. What I want to show you is that you have to rearrange it at the start. The x's don't line up, the y's don't line up, the equal signs don't line up, and you have to fix that before you even start the problem. So what we're going to do is bring that 3x back and write that top line like this. I think I said x, but anyway. Bring the 3y back, and when you do, you get that line. This says negative 6x belongs over here, and when you bring anything from one side of the equal sign to the other, you have to change the sign. So let me do that. Positive 6x plus y equals negative 6. Now, one other change here. I usually put a 1 in front rather than leaving it blank. You know that 1 times y and y are the same. And at this point, you would proceed, just to give you a little idea, you would try to get a 12x there and a negative 12x there and keep going. Okay? And if you want to keep going and try it, you should get that answer, negative 2,6. Okay, now we're going to take a major leap in quantum leap in difficulty, and these are the ones that took half a page each. And I've got one here that's got some horrendous numbers in it. And I've got it worked out pretty much all the way to the end, but I'm just going to guide you through it. These have 3 variables, x, y, and z. And you have to work very carefully and methodically. So the first thing I'm going to highlight here is the pairings. You want A to be written twice. Then you're going to pair the first time with B and the second time with C. And you could actually pair B and C, but I've asked you not to. Just do it this way every time. Okay, now you're going to try to get rid of the front variable, the x, in both of them. So you can see that I'm shooting to cancel those x's. And in order to do that, I have to multiply this line by 3, and I've already done so. That's these numbers. And this line by negative 2, and that's these numbers. And what that'll do is it'll cancel those. And when you add the lines, you get your first intermediate result there, which I call the star equation. You repeat the process on the other side. You can see that that 2 and this 5, they go into 10. So we're going to multiply this line by 5. That'll give me this. And also the rest of the numbers when you distribute all the way down there. And this line here has to be multiplied by negative 2. And you get these numbers. Now, even one slight mistake on these kind of throws you off for the rest of the problem. So just work very methodically. And when you add those 2 lines, the x disappears and gives zeros out, and you get your second intermediate result. I call that the double star equation. So once you have the star equation, that's over here, and the double star equation over here, You're going to write one under the other. And this time you're going to try to get rid of the y now that it's in front. Now, this is a good example of if you can't figure out what number to make cancel, like what does 7 and 23 go into, then simply multiply them together. And that's what I've done here. 7 times 23 is 161. So my multiplier on that top line is negative 23, and on the bottom line, just 7. And you get these horrendous numbers here, which is okay. You're going to get really nasty numbers in the middle of these problems. Now the y's cancel, and when you add those lines, you're almost halfway done or better because you're one step away from finding z. Divide both sides by 192, and you got it. Boom, first answer. Now you come over here and plug it in over here, and I covered all of this in class, so this should be reviewed to you. And you plug that z value in right there where it says z, and work that out till you get y. Then you plug that answer and the z into the top equation, equation A at the top of the page, and you can find x. And once you find x, you put them in order, x, y, z, and point format. Okay, so that's kind of the first problem done, but it's also done quickly so that you get the overview of how this is done. And I'm going to work one of them with you from start to finish. Now, I've already done the pairings, equation A and B together. Okay, and our goal here is to get rid of the front variables. So this has to be multiplied by 2. We're shooting for 4x and negative 4x here. The top line's good to copy. I'm going to copy it. The bottom line has to be doubled. Add these lines, cancels out the x. And you get 9 over here. That's the one I call the star equation. Now you do the exact same process with different numbers over on the right. We're going to shoot for 12x, 3 and 4 going to 12, and its opposite. So this just has to be tripled. I'll triple all those numbers. And I better check this. I think I know what 19 times 3 is, but just like you, I need to be careful. Negative 57. And the bottom line has to be multiplied by negative 4. Adding these lines cancels the x. And we get our double star equation. That one copies over here, underneath the other one. It's easy to make a mistake, so just do it methodically. All right, so I think 1 and 17 go into 17. I'm going to go ahead and write that down. I'm shooting for this so that we can cancel these y values. The bottom lines are already good to go. You may have noticed I cross my z's. I do that the Canadian way only because I don't want them to look like 2's. So 17 and 3 will multiply to get 51 right here. And on the other side, 17 times 9, I'm typing it on my calculator here, I get negative 153 there. And these terrible numbers in the center of the problem are going to disappear pretty quick here. Those are gone. You get 50z. And on the other side, negative 150. So dividing by 50, you find out that's actually a very friendly answer after all that heartache. And finding z is by far the hardest part of this. So now you just bring that z value up here. We'll add 3 to, let me rewrite it this way, just a second. So I'm going to add 3 to both sides. And I'm strongly suspicious here. I've made a mistake somewhere, I think. At any rate, I'm going to plow through and you'll maybe find my mistake. But this answer here is not, I probably won't have one like this. That's ridiculous. Okay. So I'm going to bail out because I'm pretty sure I've made a mistake here. And on the video, it's hard for me to find it. But I'll try here just a second. Okay, I looked it over and found my mistake here. A negative divided by a positive should be a negative. So I'm going to make that change, and you'll see in real time me trying to fix this thing here. Okay, so that needs to be changed, and we'll follow that through here. We've got a negative 3 there, and it's going to be negative 3, positive 3, and what that does is when you subtract 3 off both sides, you get 0 here, and 0 divided by negative 17 is 0. So y equals 0 there. Okay, much friendlier answer, and I just made one little mistake there. You guys have probably felt that frustration on the homework, and I understand it. That's why you got to really be careful when you do these. Okay, so now we're going to take all 3 of these and plug it in equation A, and I've got it written way at the top here, so I have to go look at it here. 4x minus 3y, looking right here, plus 1z and negative 19. I gotta go look again. 1z plus 1z equals negative 19. Okay, so we're going to take 4x plus 3 times 0, that should be easy, plus one of the z values, which is negative 3, and that's negative 19. Okay, I can cancel the 3 times 0, but I'm just going to write it. And adding let me make sure I copied that right. Yeah, I did. We're good. Gun shy now. Adding 3 to both sides, you get 4x equals negative 16. And divided by 4 here gives a pretty tame answer. Negative 4. So you put those in order. Negative 4 is the x, 0, and negative 3. So those take a lot of time, and if you actually get one of those on your test, and I'm sure I will put them on there, you're going to leave that till the very end of the test because since they take so long and it's easy to get off track. They're also very hard to find mistakes if you make one. Okay, so on this next one here, I want to just show you that you just need to rearrange this one before you start. So that's all I'm going to show you on this one is the rearrangements. Okay, anything that transfers like this first thing here has got to go to the other side of the equal sign. You have to change the sign there, but not these guys. They're going to stay on the left. You just have to keep that negative 2x negative. It just goes to the front of the other one. And now you bring over the positive 1z, and the 7 belongs where it's at. Here your negative 4y is coming over, and it's going to become a positive 4y and plop right down in the middle of the other 2. And the 15 is already good to go. It's on the right side. Okay, you'll notice that there's no x's in this line here. And so what you're going to do is you're going to put a 0x there and a 3y here. And minus 4z equals 26. And if you run into one of those, you can just erase this right there and call that your double star equation. You'll just simply pair these to cancel the x's to get the star equation. But you're looking at a gift when I've already eliminated the x, which is what that one is. And the last thing is how to handle the exceptional cases. And here it's actually easier. If you get a always true or never true statement while you're working it out, they're too hard to tell in 3 dimensions which type they are, so you're not required to. You just say, hey, this is one of those problems that doesn't have a single answer. And the correct way to say it is unique answer. So you write no unique solution. And that's all you have to do on these 3 variable systems if you run into one of those. Okay, so that does it for section 15B and 15D. And I apologize for that little glitch where I made that error, but hopefully you saw in real time me fixing it. And good luck on your homework, and I really appreciate you working so hard on this. And I'll see you next time.